Millions of engines were never supposed to fail this early, and the companies behind them knew it. We're talking about General Motors, Toyota, Honda, Hyundai. The biggest names in the entire automotive world. Brands built over decades on a single promise: reliability. Yet right now, as you're watching this, thousands of owners are dealing with blown engines, repair bills worth $8,000, $10,000, $12,000, and dealerships shrugging their shoulders, telling them this is all completely normal. This isn't bad luck. This isn't a handful of defective units slipping through quality control. This is a systematic pattern repeating itself across every badge, every price point, every continent. And the real cause is not what you've been told. Let's start with the numbers. Because numbers don't lie, even when companies do. Hyundai and Kia alone recalled over 7 million vehicles in the United States in recent years due to engine-related failures. 7 million. General Motors faced hundreds of thousands of complaints tied to AFM lifter collapse, with class action lawsuits still working their way through the courts. Toyota, the brand that for decades was literally synonymous with indestructibility, had to answer for multiple generations of engines accused of abnormal oil consumption. Honda received tens of thousands of complaints about fuel dilution in the oil of their 1.5 turbo engines. The NHTSA complaints database is overflowing. Owner forums are packed with identical stories from people who never even met each other. Lawsuits are multiplying, and the official response remains almost always the same: consumption within acceptable parameters. But if these were truly isolated incidents, why are they happening across different brands, different countries, different models, all within the same window of time? Think about what these brands actually meant just 20 years ago. Toyota was the global benchmark for reliability. The Camry, the Corolla, the Land Cruiser. Cars that hit 400,000 kilometers on routine maintenance. Taxi fleets running 1 million kilometers on a single engine. It was almost a cliche. Buy a Toyota and never think about it again. Honda was Japanese precision engineering at its finest. The B-Series engine, the K-Series, power plants that mechanics disassembled with genuine respect, reliable, responsive, long-lasting, built with a philosophy that felt almost personal. General Motors carried the legacy of American durability. The truck that lasts 30 years. The LSV8 that the entire world adopted as the foundation for every kind of performance build. An engine so well regarded that people still swap them into everything from muscle cars to off-road rigs decades after it was introduced. Hyundai had built its entire modern reputation on one thing: the longest warranty in the industry, 100,000 miles on the powertrain. That was their closing argument to every skeptical buyer. It was their way of saying to the world, we are so confident in these engines that we will personally back them up. Then something changed. And it didn't change by accident. Here's the real turning point. The moment where everything quietly started to come apart. Through the 2010s, regulatory pressure on fuel economy and emissions became increasingly aggressive. Europe, the United States, Japan. Governments started imposing tighter and tighter consumption targets. Automakers faced a choice. They could fundamentally reinvent their propulsion systems from the ground up, or they could optimize their existing engines just enough to pass the tests. Almost all of them chose the second path, because it was faster, it was cheaper, and it was just effective enough to satisfy regulators on paper. The result was a silent but profound transformation in how engines are designed. Not to last, not to survive abuse, not to perform reliably at 200,000 miles under real-world conditions. To pass tests. That is the core of everything we're about to walk through. Start with the piston rings. For decades, piston rings were designed with relatively high tension. They sealed the combustion chamber tightly, they kept oil from climbing where it didn't belong, they handled heat and pressure over long service lives. Then engineers discovered that by reducing the tension in those rings, you lower the internal friction of the engine. Less friction means less wasted energy. Less wasted energy means lower consumption numbers on standardized test cycles. On paper, it sounds like smart engineering. The problem is that low-tension rings seal worse. Oil begins migrating into the combustion chamber. The engine starts burning it, slowly at first, then progressively more. And once those rings begin to carbon up and lock into their grooves, the problem accelerates. You go from burning a liter every 5,000 kilometers to one every 2,000, one every 1,000, sometimes even less. This is not a manufacturing defect. This is a design choice with entirely predictable consequences. The engineers knew what they were trading. They made the trade anyway. Then there's the oil itself. To meet fuel economy specifications, manufacturers began recommending increasingly thin oils. From 5W30 standards, the industry moved to 5W20, then 0W20, then 0W16, and in some applications even thinner. Thinner oil means less cold start friction, better numbers on test cycles, cleaner results for the regulators, but it also means less protection at the moments that matter most. Rod bearings and main bearings depend on a pressurized film of oil to ensure metal never actually contacts metal. That film is what keeps the engine alive. With oil that's too thin, that film becomes dangerously marginal under high heat, under load, under the kind of real-world stress that test cycles are specifically designed not to replicate. And when maintenance gets neglected, when someone pushes their oil change interval too far, or doesn't check the level for months, that protection can disappear almost entirely, not instantly, gradually, invisibly, right up until the moment a bearing spins, a rod knocks, and a repair bill appears that costs more than the remaining value of the car. This is why failures cluster so often between 80 and 120,000 miles. Late enough for the warranty to have expired. Early enough to leave an owner still making payments on a vehicle with a destroyed engine. Now add the turbocharger into the equation. Over the last decade, virtually every major automaker replaced mid-displacement, naturally aspirated engines with smaller turbocharged units. A 1.5-liter four-cylinder turbo instead of a 2.5-liter 6. Same horsepower on the spec sheet, smaller displacement, lower consumption numbers. The marketing wrote itself. The reality is considerably less clean, more stress on less metal. A turbocharger operates at temperatures that push the limits of the oil circulating through it. It spins at speeds that can exceed 100,000 revolutions per minute. It depends entirely on a constant supply of fresh, high-quality oil to keep its internal bearings from destroying themselves. Under ideal conditions, with disciplined maintenance and clean oil, it functions. Under real-world conditions, extended oil change intervals, degraded oil, an owner who hasn't checked the level since last winter. That turbo becomes a liability. And when a turbocharger begins shedding metal debris into the lubrication circuit, those particles don't stay in the turbo. They travel. They reach the engine's bearings. At that point, you're not fixing the turbo. You're replacing the entire engine. Let's go brand by brand, because each story deserves to be told properly. General Motors first. The AFM system, Active Fuel Management, was designed to deactivate half the cylinders during highway cruising to save fuel. Brilliant in concept, catastrophic in execution. The hydraulic lifters that managed cylinder deactivation proved vulnerable to collapse, particularly in the presence of degraded oil or low oil levels. When a lifter collapses, the damage cascades. It reaches the camshaft, the valve train, and can ultimately destroy the entire engine block. Billions of dollars in repairs across the owner base. Class action lawsuits. And for years, GM continued installing that same system on new vehicles while the complaints kept piling up. They eventually introduced the DFM, and then moved toward removing AFM on some platforms. But only after the damage to hundreds of thousands of owners had already been done. Toyota next. The oil consumption issues tied to several engine generations, particularly the two AR-FE four-cylinder found in Camrys and RAV4s, generated some of the most organized owner backlash in the brand's modern history. Owners reported needing to add a quart or more of oil between scheduled changes. Toyota's own internal threshold for what constituted acceptable consumption was, to many, almost impossible to defend. A quart every 1,200 miles was, according to their documentation, within spec. For a brand that had built its entire identity around engines that simply didn't need that kind of attention, it was a reputational earthquake. Honda's 1.5 turbo problem hit in a different and particularly uncomfortable way. In colder climates, the engine's short-trip operating cycles were causing raw fuel to accumulate in the oil. Fuel dilution. The oil level was actually rising on the dipstick because gasoline was mixing into it. Diluted oil lubricates far less effectively than clean oil. The long-term implications for bearings and internal surfaces are serious. Honda's initial response was a software update. Whether that fully addressed the root cause depends heavily on who you ask. Hyundai and Kia's engine crisis became one of the most visible in the industry's recent memory. The Theta, two engine failures linked to manufacturing debris in the oil passages, led to a pattern of sudden seizures, sometimes accompanied by fires. The National Highway Traffic Safety Administration launched investigations. Congressional inquiries followed. Whistleblowers came forward with claims that the company had identified the scope of the problem earlier than publicly acknowledged, recall after recall. And even after the recalls, reports of continued failures persisted. Different badges, different price points, the same industry direction. It gets worse when you look at where things are heading. More turbocharged engines, not fewer. More start-stop systems that cycle the engine hundreds of times per day. Each restart happening with momentarily reduced oil pressure. Higher operating temperatures as engineers chase every possible efficiency gain. Longer recommended service intervals. Because shorter intervals make the cost of ownership look higher on paper. Smaller oil capacities that give the lubrication system less thermal and chemical buffer. Cost-cutting supply chains, squeezing tolerances that previous generations of engineers would never have accepted. And layered over all of it, software. Engine management systems that can mask early warning signs, that adjust fuel trims and timing to hide symptoms that a driver might otherwise notice before serious damage sets in. Ask yourself this. If engines designed for this decade are already showing these failure patterns at 80, 90, 100,000 miles, what does the picture look like at 150,000? Now let's talk about what this actually means for the person sitting in the driveway with a repair estimate in their hand. Warranty expired at 61,000 miles. Engine fails at 64,000. The dealership says it's wear and tear. The independent mechanic quotes $8,000 for a remanufactured engine, not counting labor. The car is still financed. The trade-in value, now that the engine issue is documented, has fallen off a cliff. The replacement engine has a 6 to 8 week wait because supply chains are still fractured, and every mechanic in a 50-mile radius has a waiting list. This is not an abstract scenario. This is the actual experience of thousands of owners who did everything right. They followed the service intervals. They used the recommended oil, they trusted the brand, and they still ended up here. That betrayal is real, and it deserves to be named for what it is. So what can you actually do right now to protect yourself? First, stop waiting for the maximum oil change interval. Whatever the manufacturer recommends, cut it. If they say 10,000 miles, do it at 6. If they say 7,000, do it at 5. The oil change interval printed in your manual was calculated to pass a cost of ownership marketing benchmark, not to maximize engine longevity. Check your oil level every 2 weeks, not when the light comes on. Every 2 weeks. Pop the hood, pull the dipstick, look at where it sits. If your engine is burning oil between changes, you need to know that before it runs dry. Use OEM spec filters or better. Don't cut corners on the one component whose entire job is to keep debris out of your engine. Let the engine warm up gently. Short cold bursts before the oil has reached operating temperature are disproportionately damaging relative to how brief they are. If you hear a tick on startup, address it immediately. If you smell burning oil, find out why. If the idle is rough, if there's a knock underload, if you're seeing blue smoke on startup or acceleration, those are not sounds and smells to hope disappear on their own. And before you buy any used vehicle, research the specific engine code, not just the make and model, the actual engine designation. Some engine families within the same brand are dramatically more reliable than others. A 5-minute search before you sign paperwork can save you thousands. Finally, before your next purchase, think differently about what you're actually evaluating. No brand is flawless anymore. The industry-wide shift toward optimizing for test performance rather than real-world durability has touched almost everyone, but there are still smarter choices available. Look for proven engine families with long track records across high-mileage examples, not just early impressions. Simpler naturally aspirated designs, where available, still offer fewer failure points than complex turbocharged units. Prioritize vehicles with strong owner communities who have been running the same platform for years because their collective experience is more honest than any press review. Be cautious with first-year redesigns. The model that's been on sale for 4 years has had its problems shaken out. The one that launched 8 months ago hasn't, and demand maintenance records, every single one. The real cause behind all of this was never one bad engine. It was never one negligent engineer or one rogue cost-cutting decision. It was a systemic, industry-wide shift in which efficiency targets, emissions compliance numbers, quarterly earnings pressure, and marketing promises were consistently allowed to outrank long-term durability engineering. The engineers who raised concerns were often overruled by the economics. The owners who paid the price were often told the failures were within spec. Millions of people trusted names built over generations. Many of them paid for that trust with repair bills, lost equity, and years of stress. But informed drivers can still come out ahead. Know your engine's specific history. Maintain it more aggressively than the manual suggests. Learn the warning signs before they become emergencies. And when something doesn't feel right, don't wait for the dashboard to tell you what your instincts already know. If your engine failed early, drop your model and mileage in the comments below. The more people speak up, the harder this pattern becomes to ignore. And if this opened your eyes, share it with someone who's about to buy one of these vehicles. They deserve to know what they're actually getting into.